Now, under section 3, we are looking at variable coefficients. Looking at this question, we can see that the coefficient of y is 3 over t. This is not a constant coefficient, it is a variable coefficient because of this independent variable t. So whenever we have such case, how do we solve it? So let's look at the solution. The first step is to arrange this in the standard order or the standard form. So y prime minus 3 over t y should be equal to t to the power 5. So always you take all the variables, which is the y, the dependent variables, and its derivative to the left hand side. Then the next thing is to find the integrating factor. Our integrating factor is always e to the power the integral of the coefficient of y. The coefficient of y here is negative 3 over t. Then dt. So this is the formula for finding the integrating factor. Now let us solve it here step by step. The integral of negative 3 over t dt. So the first thing is to integrate the top. This one, let us focus on this one. So we have the integral of this is going to be, remember that negative 3 can be written as negative 3 integral of 1 over t dt. So to integrate 1 over t, I'm going to get negative 3 ln t. So now let me put it back. So we are having e to the power negative 3 ln t. So we are going to get e to the power the natural logarithm of ln. So ln t to the power 3. And we know that the e will cancel the natural logarithm. Therefore, we have t to the power. Remember, this one will be negative 3. Negative. Because of the negative sign here, it will be negative 3. So we have t to the power negative 3. And that is our integrating factor. So my integrating factor is t to the power negative 3. I didn't bring the constant of integration because when we multiply through, it will cancel out. So now let's move on. The next thing is to multiply through by this integrating factor. So I'll take t to the power negative 3 and multiply it by the left hand side here, which is y prime minus 3 over t y. Then should be equal to t to the power negative 3. I am also multiplying it by the right hand side, t to the power 5. Now let us expand this. I will get t to the power negative 3 y prime. Then this times this will give me, the t will cancel the t will cancel one of the t's here. So I'm going to get 3 minus, okay, so let me take it like this. This is a denominator. When it goes up, it becomes t exponent 1. So I'm going to get 3t exponent 1, and if I should multiply through, t exponent negative 3 times 3 times t will give me 3, then negative 3 minus 1 will give me negative 4, so t exponent negative 4y should be equal to, then this becomes t to the power 2. Now when we get to this point, let's focus on the first part. All this expression is in a form of a product rule, which can be simplified as the integrating factor t exponent negative 3 multiplied by the dependent variable y. Then you take a total derivative of it. Now this whole thing is the same as this, because if I should expand this, I'll get this. Let's take note of that. Should be equal to the right hand side, which is t squared. Now the next thing we have to do is to integrate. So let us integrate. Take the integral of both sides. When you take the integral of both sides, the integral will cancel the derivative here. So I have t negative 3y should be equal to, if I integrate this one, I'm going to get t cubed over 3 plus a constant of integration. Now I can write this as t negative 3y, then this t cubed over 3 will come to the left hand side to be negative t cubed over 3. All should be equal to c. Then when I take a total derivative of it, I'll get t negative 3, or let me put it this way. It means that from here, if I should take a total derivative of this, then it means that the derivative of a constant will be 0. So this will become 0 here. Now this is what we call total derivative. This expression is what we call total derivative. Total derivative is always equal to 0. Let's take note of that. Then from this total derivative, the inner function, this function is called a potential function. It's called a potential function. Now you can see that this potential function is a function of t and a function of y. So the independent variable t and the dependent variable y. So I can write it as this potential function is a function of the independent variable t and the dependent variable y of t, which is equal to, if I take its derivative, then it is equal to 0. But if I don't take the derivative, then it means that my potential function will be equal to a constant. Without the derivative, the potential function is a constant. So let us find that potential function. The potential function is what is inside the bracket. So we can say that t negative 3y minus t cubed over 3 should be equal to a constant. Then we can easily solve for y. So let me write it here. We are now solving for y. So let me write the expression here again. T negative 3y minus t cubed over 3 should be equal to c. So what we have to do is to divide both sides by t negative 3. If I divide here by t over negative 3, then here 2 over t negative 3, then here t negative 3, This will cancel this, so I have y here. Then this t negative 3 will go up. When it goes up, it will be t to the power 3. Then there's another t to the power 3 here. So multiplied by, so let me just write it straightforward. It will add to be t to the power 6, all divided by 3. Then this one also goes up to be c t to the power 3. And finally, we can express y as a function of t, which is equal to c to the power t 3. Then this goes there to be plus t to the power 6 all over 3. And that is the solution to this differential equation.